In fact, during this course, we want to talk about the information and communication technologies. Different technologies which are used in communication and information. So we talked about the syllabus of this course. First of all, we will have an introduction to the digital age, and we will talk about the digital systems, meaning of the digital world, and also meaning of system. We will see that what is the system and what is the signal and different types of signals. And also I will talk about the binary systems, binary numbers, decimal, octal numbers, and hexadecimal numbers. And you will learn about all of these phrases and terminologies. After that, I will talk about the operations of systems and describe the system operation. I will talk about the block diagrams and so on. Then, as I talked before, and I illustrated to you that what is the sensors, and I gave you an example, and I said that suppose that this is my mobile, which is a digital device. Actually, most of the time we use these smartphones instead of cell phones these days. All of you have a smartphone. These smartphones make communication between us and another one. So we need one to know that what is the application of this device and what kind of devices are used inside the digital devices like smartphones. And I said that our microphone is a sensor and a speaker is an actuator. We will talk about the different types of sensors, actuators, and so on. And also combinational and sequential logic circuits. What is the meaning of logic circuits? Actually, you will see that the AND or NOT gates, all of them are a logic element. When we connect these logic elements with together so that we can give the input and get the output, this system is called logic circuit because we used the logic elements like AND or NOT gates. We said that these logic circuits are combinational logic circuits. Combinational logic circuit and sequential logic circuits. You will see that one of the sequential elements in logic circuits are flip-flops. We will learn what is the flip-flop at this chapter. Then in the another chapter, we will learn about the different types of signals because the signal is sent from our digital devices to the another one. Everything in our worlds in aspect of electrical and electronics engineers are signal or system. Okay, then we talked about the modeling the random data. You will see that our signal, which are sent from one place to the another place, some noises is attached to this signal. So we need to separate the noise and the information and data signal from each other. So first of all, we need to learn what is the meaning of noise, what is the noise data and noisy data. So at the another chapter, we will detect the data signal with the noise signal with using some methods. In sending the data, because of the security issues, we need to encrypt and compress the data. So there are so many methods in the case of data encryption and data comparison, and also data structure and error correction. Then I will talk about the data networks. What is the meaning of networks? What is the internet, intranet? What is the difference between them? What is the IP? Different types of protocols. Our websites, how they work in the through the internet, and so on. And symbology, how the barcodes work. We will talk about that. At the end, if we have more time, I will talk about the application of Excel in electrical and electronics engineering. Okay, let's say that a word computer comes from the word compute. Compute means calculate. Actually, computer is a device capable of performing computations and making logical decisions at speeds of million or billion of times faster than we can do this computation. For this reason, we need to computer, because some operations, some problems, so many problems actually, that the human beings cannot solve them, the computers can calculate and compute them. But how the computers do that? The computers solve the problems using programs, which is called computer programs. And the programmers or developers write these programs using programming language like C, C++, Java, JavaScript, Python, and so on. Okay, this computer is composed of various devices like CD-ROM, RAM, mouse, disk, monitor, memory, and so on. All of these devices that there are physically are called hardware. The programs that run on a computer are referred to software. A computer is also called a data processor. Data processor. Why we said the data processor for computers? Because the computers can store, process, and retrieve data. Okay? The process of storing, retrieving data is the meaning of data processor. Okay, now I want to talk about the data and information. We said that the activity of processing data using a computer is called data processing. Actually, data is our raw material, which is used as an input of digital devices like computers. So we give data, which is the raw material, which is used as an input in computers. So we capture the data, manipulate the data, and get the result. This is the data processing, and at the end of this processing, we can get and receive the information as an output. It means that we will have data in the input of a system and information at the output of the system. Here, actually, I want to show that the meaning of the data and information. This is a hen. This hen is like a data. We cannot eat it. We cannot use it. But we need to do some process that can use it, can eat it. So this cooked hen or chicken actually is information. This cooked chicken is information, and this hen or chicken is data. Some processing we need to do through this data to get the information. And in the computers, also the raw data as an input we give to the computer, and some process will do inside of the computer, and we can get the information as a user from computer. This is the meaning of data processing in a digital device and also computer. Okay, I would like to talk about the generations of computers. We have 5 different types of generation in computers. First generation, which use the vacuum tubes, or very large number of vacuum tubes are connected together to make a first generation computers from 1940 up to 1956. 2 prime examples of first generation computer devices are UNIVAC and ENIAC. This is the first generation computer, as big as possible. This is the inputs, and these are the output that gets from this computer. This is a binary code using zeros and ones. I will talk about the digital systems, and you will see that the meaning of digital is using zeros and ones in digital systems like computers. All of the things that we need to introduce and define for computer need to convert to the binary system. It means that need to convert to the zeros and ones, and as a code we can define the everything in the computers. The installation was so difficult, and the bugs are so many. Okay, the application of the first generation was the scientific computation, the simple computation that they need to do that. Okay, that was the first generation. I wanted to show you that I want to you have an imagine about the computers and the generation of the computers. As you see, the first generation computers was as big as possible. Then with the improving the technology, the transistor is substituted instead of vacuum tubes. So the second generation started to use the transistors instead of vacuum tubes. And the second generation occurred. Using transistors, the computers getting smaller. Okay, as you see here, this is the circuit of actually using vacuum tubes. These are the vacuum tubes, and this is the dimension of the transistor. Okay, that was the second generation. For the third generation, again, with improving the technology, with advancing in the technology, some electrical and electronics engineering can produce the integrated circuits, which are the collection of transistors. Thousands of transistors is connected together as an integrated circuit and make the IC. This is the IC. Each of these pins has an application. And this is one of the third generation computers. As you see, these generations computers are getting smaller than the second and first one. And also these generations are faster than the second generation and also cheaper than second generation. Okay, in the fourth generation, the Intel, especially the Intel and then AMD, started to produce the microprocessors. Now, in the microprocessors, thousands of ICs compacted together and make the microprocessors. Thousands of integrated circuits built the microprocessor. The operating systems start to use the Windows, again improved. Okay, that was the fourth generation at the end. Now today, these days, in our world, in the digital age, the robotics, some other systems used artificial intelligence methods. Actually, the fifth generation computers completely based on the artificial intelligence. This is the meaning of artificial intelligence. Actually, in the artificial intelligence, the engineers are trying to model the human's brain. The human's brain. They wanted to know that how the human beings behavior and behave according to some other problems, and how we think, how we can solve the problem, how the human's brain works when the human beings are thinking. So, as you know, in your biology course in the high school, You know that in our brain, we have some neural networks which are connected together in a complex form. So the engineers try to find the structure of neural networks in our brain. For this reason, the new method called artificial neural network, which is a section of artificial intelligence. And the task of these engineers is learning about the neural networks of human beings. Another methods are using the expert systems, artificial neural networks, pattern recognition, classification methods, deep learning, SVD, and so on. All of them are called artificial intelligence. So thinking computers using artificial intelligence. All of these robots use the artificial intelligence methods.